So, continuing on with parabolas, we've got two more examples to go. Remember, this will be included on your quiz and test. So you do not have to memorize all this. You just have to be able to use it. Our penultimate example, we're going to prove that a graph is a so we're going to prove that this relationship is a parabola, and then find the vertex, the focus, and the directrix. And then the last example, we'll be given a graph of a parabola, and we have to come up with the equation. All right. So first of all, I have to prove that this is a graph of a parabola, which essentially means taking this equation and making it look like one of these two standard equations. If I can make this look like this while following all the rules of algebra that we know, then I proved it. Now, which one is it? Is it one facing up or down or facing left or right? Well, notice the y is squared, and that only occurs in the parabolas opening up left and right. So I'm not using that. I'm focusing all on this. And what do I do here? Well, here we actually complete the square. This is the practice that we're going to use. We're going to complete the square. Completing the square is more common in the later sections, but we're going to use it right here. So how do I complete the square? When we practiced a couple days ago, I said get all the x variables on the left side, all the numbers on the right side. Well, here we have to recognize that the square that I'm going to complete contains the y values. So I'm going to keep this on one side of the equal sign, and these two I'm going to move over on the other side. So remember, I want to complete a perfect square trinomial. I don't want to mix in y and x in the same trinomial. I want to keep it with one variable only, and that variable is going to be the variable y. So my first step is going to add 8x, subtract 20. Now, notice you've got 1 as the a value, b is -4, and do you remember how to complete the square? You take half of that b value and square it. So half of -4 is -2. If you square that, you get +4. Of course, do it to both sides to keep the balance. Now, this factors into y minus 2 squared. And -20 plus 4 is -16. So you see how it's shaping up to look like this, I hope. We know that k is 2, for sure. But this 8x minus 16 does not look like this. What could I do? Factor out an 8. And we've got it. This looks exactly like this. I know that k is 2, h is 2, and 8 is 4 times p. So that's all we need to do. This is the proof. And what else did it want us to do? Find the vertex, find the focus, find the directrix. Okay, well, the vertex is hk. And again, pulling from here, I know h is 2, k is 2, and 4 times p equals 8. So p is also 2. So 2, 2, 2. The vertex is 2, 2. The focus is h plus p, comma k, so 4, 2. The directrix is x equals h minus p. Don't forget to write x equals because the directrix is a line, so you need an equation. The focus and the vertex are just points, but the directrix is a line. And then clicking, you can go to Desmos and not during the test or the quiz, mind you, but in your process, in your path to understanding all this, you should be having one hand on Desmos and checking these graphs out. So I typed this parabola in as it was given to us, and there it is. So the directrix is x equals 0, and not a function of x, fails the vertical line test many, 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 many times. Last example. Write an equation of this parabola. Oh my goodness. So this parabola is facing up. That means I'm using this, not this. So just to make it totally clear, not even going to look over there. All right, well, what do I know? I know the vertex, don't I? The vertex is -1, 3. So that's good. So h is -1, k is 3. What do I have to do here? Find an equation. So remember, to get the equation, I need h, p, and k, And I know the vertex, so I know H and K. I just got to find P somehow. 3, 5 is one ordered pair. So 3, 5 is one specific relationship on this parabola. So remember, X and Y represent all the ordered pairs on this parabola, and there are an infinite amount. 3, 5 is just one of them. So I'm going to temporarily plug in 3 for X and 5 for Y. That's temporary, just to serve my purposes, just to find P. So here is the standard equation. I plugged in H and K where they go. And now I plug in 3 and 5. This is just temporary because some students will tell me like this is the solution. This is not the solution at all. The final answer has X and Y. You need to generate all the ordered pairs. And now we just solve for P. I've got one equal sign and one unknown. I can do it. 3 plus 1 is 4. And 5 minus 3 is 2. Don't even need a calculator, do we? 4 squared is 16. This is 8. So P has to be 2. And there's only one more square. I'm almost done. I know H and K that were given right away. And now through algebra, I discovered P. And some students stop here, and that's a real tragedy. You have to find the equation. So you have to plug in all those things. P is 2. So remember, this is 4 times P. So therefore, it's 8. This is the standard form. This is the equation of this parabola. And if we just indulge me for just a second, if we go to Desmos and type that in, here's what we found. Notice the vertex is -1, 3, and it definitely does go through 3, 5.